Hello, Dr. Sanders. This is Titus Rehard, and this is my CSC313 Assignment 4. This is the ray tracing assignment with the teapots. So I'll go through the code when I pull up my Word document, but first, just to show that it works, I'm not going to actually run it because it'll take a little while, but the output PNG shows we have the teapot with some brighter sections, and then we have some shading, we have some darker sections. Yeah, I think that's pretty much it here. So let me pull up the code, we'll go through it. So, code is decently self-explanatory. We start off with, we just build the scenes, we set up the camera, we do the background stuff, we create threads. Basically each thread is going to be a row of pixels that they're calculating. And then we'll write the image. See, the important things in here, we have a bunch of classes that are just building classes. So this is how the camera works, this is what we're looking at, what the position is, what the field of view is, all that thing. The vector is interesting. There's a bunch of different types of them, depending on what we're pulling in. And then it describes what we mean by faces. Ray tracers, where stuff starts to get interesting because it's actually building out the rays and determining intersection points and where the quote-unquote light beams or rays are emanating from the camera. Basically, in a normal scene, light emanates from the light source, and then bounces into the camera. When we render things, we treat it as if light emanates from the camera and then bounces around, and then we update the color or the shade or whatever of the object based on how many light rays have hit it and if they were reflected or if they were just straight rays. Intersection, decently self-explanatory, just did you hit it basically. We parse the OBJ, that makes sense. Rendering, then we get down to what we had to actually change. So in here, in the trace ray, we get the vertices of each face. This is what actually does the drawing, basically. So we loop through all the faces, we get all the points, so then we calculate the intersections and if they were hit, and we add closest intersection to it. Then we calculate the reflection here. You build out the reflected rays, and then you assign it a color. You have the RGB, and then it'll take the minimum of all of them between 255 or what we actually got. That just means that we're not going to ever go above 255 because that would give a color that doesn't actually work. But what we added here is a way to check, basically, instead of building out rays that are quote-unquote shadow rays or dark rays, we built a way to check if there was ever a ray that hit an area. So if we compare the reflection directions in the X, Y, and Z and compare it to an arbitrary reflection gate that we set up, which is just how much is it being, the direction changing. If we see that all three of them, the X, Y, and Z haven't changed, then basically we haven't hit that spot. So we give it a shadow. Instead of calculating how many non-rays hit it, we calculate the spots that aren't hit by the light rays, if that makes sense. And then we assign the color and we print it out the way we normally do. This was pretty self-explanatory. Honestly, one of the bigger problems with this is just getting the classes to be static, because some of them with the newer version of Java wouldn't work unless they're static. So yeah, that's that. Thank you so much.